Hi, Ms. Travis here. Today we're going to begin with the very basics of geometry, starting at the very beginning with points, lines, and planes. Before we can get into points, lines, and planes, we need to know what a definition is so that we can kind of get our basis there. A definition is a statement that clarifies, or explains the meaning of a word. It is formed using other defined terms. So if we're talking about defined terms, then what are the undefined terms? In order to define these words, you would need to use words that need further defining. So they remain undefined They are the basis for all of geometry. So what are these undefined terms? We have point, line, and plane. What is a point? A point, you see here as an example, we have what it looks like, point P, but it really has no size. It is rather the indication of a location, and we represent it with a dot and a single capital letter, but it's not really the size of this dot. It is more abstract than that. This is just our representation of a location. A line is a series of these points that we're talking about here that extend in opposite directions without end. And they can be named by any 2 points on the line or a single lowercase letter. So, for example, we have this line here, and again, it is a series of infinite points that we kind of connected to look like a line that we can draw, but it's really more abstract than that. So we can imagine that this line goes on forever and ever and ever in both directions. So we have drawn a section of that line because we can't look at it one that goes on forever because that is impossible. We represent the infinite distances with these arrows, and then we've pulled out a couple of points on this series of points to put with dots there and label with names A, B, and C. So that we can use that to name this line. We could also use this cursive script lowercase letter here, T. So some options for naming this line would be line AB, just picking out 2 of the points and putting a little mini line above it. Line BA is acceptable, same thing. CA is acceptable. BC is acceptable. You could continue on with like AC or BC, or you could say line T. And it's because this line is also named with this little cursive script letter here. Oh, and we've just done that, but give another way to name the line. We could name it, one of the ones I said was AC, and we're going to draw the little mini line above it. While we're talking about what a line is, we're going to talk about what collinear means. And it has the base word in here of line. And so collinear is a way to describe points that lie in the same line. Our third undefined term that we're going to talk about today is plane. And a plane is a flat surface It's another one of these ones that are too abstract for us to be able to actually draw, so this is how we represent it in geometry. It's a flat surface with no thickness that extends forever in all directions, and it can be named with a single capital script letter, or if you don't have that capital script letter, it can be named with at least 3 non-collinear. So here's a way that we're going to use this word by saying that we're not talking about collinear. We need non-collinear points to name a plane. So here we've got an example of a plane. Again, it doesn't really look like this because it's too abstract. This is just our drawing to represent it. We could name this plane plane M. We could name it plane A, B, C. Another way to name this plane might be plane, let's go CAB. And again, we have a definition kind of within this term called coplanar, similar to collinear. The base word is plane, and it means points and lines that lie in the same plane. While we're talking about the basics of geometry, let's talk about some basic postulates that relate to points, lines, and planes. What is a postulate? A postulate is an accepted statement of fact. And here are a few postulates. Through any 2 points, there is exactly, so if we're looking at 2 points, how many lines could we make through 2 points? And there's only one that can go through exactly 2 points. If we have 2 lines, like so, that intersect, then they intersect in exactly 1. So where they cross those 2 lines, it is exactly 1 point. Now if we have 2 planes, so remember this flat surface with no thickness that extends forever in all directions. If we have 2 planes that intersect, they intersect in exactly 1 line. And last postulate, through any 3 non-collinear points, there is exactly 1 plane. All right, let's see some of this in action. We've got some practice problems down here. A, B, and C. Problem A, we have some lines that are intersecting. We've got some intersection points that are labeled, and we've got some extra points within the line L and line N that are labeled with B and D. So once we know kind of what we're seeing here, let's read the question and analyze what we're to do. Are the 3 points collinear? So we've got some points listed here for question 1 and 2. It asks us if they are collinear, name the line on which they lie. So first up, we're going to look at points C, A, and E, and we're determining if they're collinear. We're going to look back up here. Collinear, it means points that lie in the same line. So point C is here, point A is here, and point E is here. And so we need to see, do they lie in a line? And so C, A, and E, we can see that no, they do not. Now let's look at number 2, A, D, and E. We have A here, D here, and E here. These 3 points do lie in the same line. They are collinear, and it asks us to name the line on which they lie. It is line N. For question B, we have a rectangular prism here, and the sides of the prism are represented by some planes. Name the two planes that intersect at line RV. So we have line RV here. I'm going to kind of draw on here so we can see it a little more clearly. It's that back corner. The two planes that intersect at that line. So we've got our bottom down here. If you can imagine the bottom of the plane, that is going to be plane. I've got to name it with 3 non-collinear points. So we'll go R, S, W. And I'm running out of room to write the word plane, so I'll just say planes, RSW, and then the back plane back here that sits along this back edge will be QRV. So that should say planes, RSW, and QRV. Then it asks us, using the same diagram in B, to name another point in the plane TQR. So TQR is here, so we're looking at this plane over here on the side of the box. The other point in that plane is point S. So we can just say S. Question C asks us to use the words always, sometimes, or never to fill in the blanks to make true statements. So number 1, 4 points. So if you imagine 4 points like Q, T, S, and R, blank coplanar. So you can see here these 4 points are, but you could look at point Q, T, R, and W and notice they are not in the same plane. So sometimes they are, but sometimes they are not. Number 2, a plane containing 2 points of a line blank contains the entire line. So if I've got two points in a line that always, sometimes, or never contain the entire line in a plane. So I've got a plane. Let's just imagine this plane. We'll go back to this one that's highlighted here. QRST here. And I've got 2 points of a line, so Q and T. And if this plane goes on forever in all directions and the line goes on forever in all directions, this would be always true. For number 3, 2 lines, always, sometimes, or never, meet in more than one point. 2 lines always meet at more than one point, sometimes meet in more than one point, or never meet in more than one point. Well, if we go back up to our postulates, 2 lines intersect. They intersect in exactly one point. So this is never going to be true, that they meet in more than one point. Because we learned above that they always meet in exactly one point. 3 points are always coplanar, sometimes coplanar, or never coplanar. Well, we know that 3 points for sure are sometimes coplanar because we've got some examples here and here. Can we imagine 3 points that are not coplanar? Try to envision an example of whenever you can have 3 points that are not coplanar. You might say, what about points Q, U, and W? This plane is not drawn, but if you imagine a diagonal plane that goes through Q, U, and W, there is a plane there. So 3 points are always coplanar. And we can actually look back up at this postulate and see that we always have exactly one plane through any 3 non-collinear points. So this makes that always true. 2 planes always, sometimes, or never intersect in exactly 1 point. 2 planes blank intersect in exactly 1 point. So now we're looking at planes and their intersection of points. And 2 planes can't intersect at a point. 2 planes intersect, they're going to intersect in 1 line. So this is never true. We cannot have 2 planes intersecting at exactly 1 point. All right, last one. Intersecting lines are blank coplanar. If we have 2 lines that intersect, like here, or if we had a line intersecting this one, would they be in the same plane? Always, sometimes, or never. And if they are intersecting and they are lines, then they have to be in the same plane, which makes this always coplanar. All right, so here's a quick little overview of points, lines, and planes. Thanks for watching.